Hello, we're going to be looking at the Quick Start Lesson 1 from the SewerCAD User's Guide. So let's go ahead and get started. What we have to do is come over here to Bentley and enter the program itself. So let's get it SewerCAD version 8. And what we're going to do now is start to enter the data. So I'm going to create a new project, and we're going to enter the data about that new project once it gets set up here. So we're going to be entering information, for example, a title and the engineer and such on the project. So I'm going to over here is come over here to project properties, and my title is going to be lesson. And then I come over here and want to have it as the engineer will be me, and you'll enter your name on here when you're doing a project. And over here is Gateway is the company, and click OK. And now what I want to do is set some of the defaults, the options for the project. So I'm coming over here to Tools and clicking on my tools, and what I have is options, and on my drawing I'm going to have it be schematic so that I can set the links, the units later, that this is not a scaled drawing. My units, I want to make sure they're metric or System International. Indeed they are, so I'm clicking OK there. And now I can move on to go ahead and setting up my project. Now I'm going to be putting together the schematic. There are going to be some differences between the schematic network that is shown in the user's guide and what we're drawing. It's because there are some naming conventions that have been changed, so I'm going to call those out as we go through. Now over here what I'm going to do is start off with a conduit. You see I have a manhole. I'm now coming over here. What I want to transition to is a wet well. Now I put the wet well in, and that wet well is going to feed a pump. So I'm going to now come over here. I want to have a pump, and now I have at the outlet of the pump is a pressure pipe. And now I want to come over here to an outfall, and now I'm done with this portion of it. What I want to do next is put in a second sewer line that will feed into this one. So I'm going to come over here on layout again, pick the conduit, come over here, and here's my second manhole. And now what I want to do is when I come over here, I want to transition into this conduit over here, this sewer system. So I'm going to come over here and do a left click on it, and it asks me, do you want to split the conduit one? And my answer to that is yes. So now what I've done is, you can see here's the first difference I was calling out, is that this had been labeled JC-1 in the user guide, and this is now labeled as T1 for transition. So be aware of that. Now I'm done, and I have all of my information on the layout done. So I'm just going to go ahead and tidy this up so it looks a little bit more like what I have in the drawing. And you can see over here is that there are some differences. Now, in the drawing on the user guide is I have C03 is called P1. C04 is P2. And over here, this would be P3 in the user guide. It is actually designated here as C05. Now, what I have is this is designated FM1, FM2, and FM3, and over here they're designated P1, 2, and CO2. So I'm going to actually be changing this. I want this to be a pressure conduit. So I'm going to come over here and do a right click and pick where it says morph conduit to pressure pipe, and now I have that one as being P3. So now that I've done that, we're going to progress to adding in information about all the different portions of the sanitary sewer system we've just diagrammed up. What you'll see is I now have moved on to part 2, which is on page 3-56 of the user's guide on entering data. And we're going to be doing that in a variety of ways. We're going to be doing the properties editor, flex tables, and other ways of being able to enter information. So the first thing we're going to do is we want to enter data in on the outfall. So I'm going to do a double click on this one over here. And you can see over here that per table 3-1, what I need to do is have a 16 meter for the ground elevation. And if I leave this as true, then my rim elevation is the same, which is what corresponds to that table. And over here is the invert elevation is 14. And I've got to correct that. There we go. I want to make sure I have a free outfall. So now I'm done with table 3-1. I'm going to progress on to the manhole data for table 3-2. I'm going to click over here, come over here to manhole number 1. You can see it's highlighted. And now what I'm doing is I'm going to come over and my ground elevation is going to be 11.1. I'm going to make this false because I don't want to have my rim elevation being the same as the ground elevation in this case. So now it is, you have it as 11 meters. My invert elevation is going to be 9. I do want it to be circular, but my diameter I want it to be 1 meter, so I'm going to change the units. Do a right click, units and formatting, over here to calling out meters, click OK, and change this to 1.0. What I want to do is change my physical structure losses to being standard and having a unit here of 0.25. So I've got manhole 1 specified. I want to now move over here to manhole 2. So let's see, here's manhole 2. And in this case, I want to have an elevation of 11.1. In this case, this is going to be true. So my my rim elevation is 11.1. My invert elevation is 9. It is a circular structure. Over here it is now, since I changed it for manhole 1, it is now diameters in meters for manhole 2. I want this again to be 1, and I want to change my structure losses to being standard and 0.25. So now I have completed entering the information from table 3-2 for the manholes. Progressing on further, what I have now is on the JC1, which is actually designated over here as T1. So I'm going to put that information in. And over here it says from table 3-3 that I need to have the elevation from ground as being 12 meters. Over here the invert elevation is 9.2, and let me see, I got the elevation to the top is not being an A, but that's going to be 11, and I want over here this is going to be standard and 0.5, and then over here the transition length is 1 meter. So I completed entering the information for table 3-3. Next I'm going to move on to the wet well information. So I come over here to W-1, which is the wet well, and over here I have from table 3-4, I want the elevation at the base to be 6 meters. So here I have is 6. My level minimum is 6. Oops, that's not right. I want to be 6.0. Enter. Okay. My initial level is going to be 8 meters. The maximum level is going to be 10. What that's doing is saying that I have a wet well that is going to go anywhere from the being empty at 6 meters to maximum height at 10 meters with a initial level at 8 meters being in there. It was going to be a circular structure, so that's fine. My diameter is going to be 3 meters. This is entering data again from table 3-4, and my elevation ground is going to be 10.5. So now I've entered the information and I'm complete with the information I need to add from the properties table here. What I'm going to be doing now is defining my pump. So I'm going to click out of this, and what I want to do now is go over to the pumps definition from the components menu, and here's pump definitions. So I'm going to be adding a new one, and over here I want to call this PMP1. So you can see that I now have moved on to the information I need to add from table 3-5, and what this is my flow rate is going to be in cubic meters per second, not liters per second. So I need to change that. And what I'm going to be doing is I need a pump defined as standard 3-point with gradually varying flow. And now I have all the units in the correct units, all the flow on the head. So from table 3-5, I have 0 as the initial flow. I need 53.33 here. What I need now for a flow of 0.25 cubic meters per second with a head of 40 meters, and lastly a 0.5 cubic meters per second flow, and 0 as far as my head. And you can see now it's defined my pump. Here's my pump curve. So I can close the pump definitions, and what I need now is double click on PMP1, and I get this information up here. And what I need to do is on the properties editor here is enter data from table 3-6. So what I first need to do is my ground elevation, which is, where's my elevation? My ground elevation, which is right here, is going to be 7.8. My invert elevation is 7.8. My pump definition is going to be not none, but I want to be PMP1. So now I've defined that, put the data in for the pump from table 3-6. So I'm complete with that. Moving on, next to what I need to do is have for my junction 1 is come over here, and I need to have a double click on it, come up with the properties, and I need to have an elevation of 13 meters. So this is elevation of 13 and a ground elevation of 14.2. So now I'm done with that, and I can get out of that one. Next, I'm going to be specifying some information for the conduits on the flex tables. So I need to come over to the flex tables, and the flex tables can be found in View. Come down here to Flex Tables, and I'm going to be putting in conduit information. I'm going to double click on that now. What you'll notice is that, as I talked about previously, is that there is a difference between the schematic that is illustrated in the user's guide and what I have over here, because SewerCAD is now using a different naming convention. So over here you see P1 in the user's guide corresponds to C03. That P2 corresponds to C04, and P3 corresponds to C05. What I want to do next is check that the data that I need to enter from table 3-7 is all up on this over here. So I need to have an invert start and stop. Here's the invert start. Invert stop is okay. The conduit shape is next, which is over here, is circular. I want the material, which is way down over here. So I do have material. The Manning's N is over here. Diameter is to be in millimeters. It is specified over here as in meters. I'm going to change my units to millimeters. And then you need to have a user-defined length, which is fine. I do that over here. So let's go ahead and enter the data from table 3-7 over here. My invert start is going to be, and these are in order because C03, 4, and 5, which correspond to P1, P2, and P3 from the schematic in the user's guide. So over here I have 10, 9.5, and then finally another 10. Now I've done that. Now for the invert stop, what I need to have is 9.5, 9.1, and 9.5. So now I have that entered. All of my conduit shapes are circular, so I'm fine there. My material is going to be concrete in all instances. So now I'm entering concrete here. I have the material for each one. Manning's friction factor of 0.013 is already entered. My diameter is to be in millimeters. And 200, 200, and 200 in each case. And my user-defined length is going to be 100, 70, and then 100. So now I'm finished with the conduit table. So now I'm going to click out of that. What I need is the pressure pipe table. But before moving on to the pressure pipe table, what you'll notice is that I have a difference. The schematic in the user guide has FM1 corresponding to P3. So this would be FM1 in the schematic in the user guide. That FM2 corresponds to P1. in the user guide. And lastly over here is that P2 corresponds to FM3 in the user guide. So what I need to do is make sure when I'm entering data that I'm careful to make sure that I have the right correspondence for the data that's in table 3.8 and what I'm entering. So I'm coming over here is I'm going to double click on the pressure pipe table. This enters up, and what I need to have is the invert start and stop, which has already been defined because the invert elevations are calculated based on the elevations upstream and downstream nodes. So I don't have the ability to enter those, but do I have the invert start and stop? So here's this, let me see, yep, here's the invert start and stop, which is going to be automatically entered from data that's already out there. So I need to also now look at, do I have the user-defined length? So indeed I do have that, and yellow means I can't enter data in, but what I do is I can click over here, check these boxes, and yes, I know I can define my user-defined length. And what I want to have is now a diameter in millimeters, which I have correctly, and material. So the material in all cases is cast iron. So now I've entered that material in there. My diameter for each one of these is 200 millimeters. Now I got to be careful starting here is that my P1 corresponds to FM2. So that has over here for user-defined length, FM2 has 200 meters. So over here, my P1 corresponds to, P1 corresponds to FM2, and I screwed that up. That is to be 200 meters over here for FM2, which corresponds to P1. My P2 corresponds to FM3, so I have a user-defined length there of 100 meters, and then FM3, which is I'm getting this all screwed up, sorry. My P2 corresponds to FM3, which is 100 meters, and P3 corresponds to FM1, which is 1 meter. And this is what your table should look like when it's all done. So now I've finished with the pressure pipe, and what I am going to go is come back to the infiltration data for gravity pipes, which is the conduits. I need to come back to the conduit table, and I know that it does not have any infiltration information, so what I come over here and look at is I'm going to enter in that, I'm going to edit this table. What I need to have is the infiltration type, the infiltration loading unit, and the infiltration rate per loading unit. So I come down over here and looking for infiltration. So let me see here. Here's my infiltration type. My infiltration loading unit is what I do want to have next. And then the infiltration rate per loading unit. Those are all moved over. Those are the last items on this table. And you can see over here is that these are yellowed out. I don't have the ability to enter any data in here yet for the infiltration loading unit or the rate. But now I want to come over here and I want to have this as link length for each one of these. And now I can come over here and I want each of these to be meter, meter, meter. And then again, I have to be careful over and here that I have this all corresponding correctly. Let's see that C03 is P1, yeah, these all correspond directly. C04 is P2, okay, so I can just, this is going to be 0.25, this one is 0.05, and lastly 0.03, and now I have my infiltration data entered in. And I can click out of this because I've entered all the data I need to here. And what I'm going to do now is come up with steady state loading, which is information on the buildings that and the facilities that are going to be discharging into the sewer system. So in order to do that, I'm going to get rid of the flex table. I come over here to components, and what I want to select is the unit sanitary dry weather loads. And let's see, where is that on here? And I don't want that. I want to come over here and look at the unit sanitary dry weather loads. Which is down over here. And once I'm in that, I'm going to be loading in some predefined information. The predefined information is going to be found over here. So I want to import information from the library. The unit sanitary dry weather loads. If I come down over here, what I'm going to be doing for this example problem out of the quick start library lesson is come up and I want apartment, a home, the average and better, a hotel, residential hotel, resort, a medium school, shopping center, and a theater. So I'm selecting all those. There's my apartment. I want to come over here to home, average, home, better. I want a residential hotel. So here's the residential hotel. I'm going to have a resort specified. I have that, a medium school. And a shopping center per employee. And then a theater. So now I have selected all the items that I want to have. I should be able to come down here and click. And let's just verify that I do indeed have everything I wanted. Have the apartment, the average and better home, the residential hotel, the resort, the medium school, shopping center per employee, and theater. So I do indeed have all this information entered in. So now that we have defined the unit loads, we're going to assign them to the nodes in our schematic model. So what I can do now is close this out. And now that the unit loads have been defined, we're going to assign them to nodes in the model. So what we're going to come up over here and do is under Tools, and then we're going to select the, let's see, where is it at? The Sanitary Load Control Center. Click that, and yes, once we do this, it can't be undone. So we can't cancel or undo support. So now we have, click this, and we now are going to be able to specify the sanitary loads. So we're going to come over here and do is for manhole number 1, is click on that. And we want to come over here and pick new. and then add unit load to element MH1, which is manhole number 1. So I come over here to the unit sanitary load, and at this point we're going to pick the apartment, and we want to look at the loading count. And at this point we're going to be entering in 2,000. So now that's accounting for the apartment. Now for manhole number 2, we want to click over here and have the resort. And we're going to again come over here, and for the resort is enter in 2,000. So next off for manhole number 1, over here we're going to add in the home average. And let's see, we're going to enter 3,000 over here. And now we're going to continue on with the information, the loading rates from table 3-10 or 3-10, the sanitary load assignments. So we're going to come over here and highlight this one for manhole number 1. Want to do new, add a unit load to element MH1. So this one over here is for home and better, and what we want to do is have a count there of 2,000 for MH2 for the second manhole. We're going to again come over here and come over here to new, add a unit load to element MH2, and we want to have the hotel residential. And we want to have a count there of 1,000. So I've now assigned the loads for the manholes. We want to come over now is over here to the wet well, add a sanitary load. Yep, that was not correct. So for the wet well, we're going to come over here and we're going to initialize unit loads for all elements. And now we have the wet well, and over here again going back to table 3-10 for the wet well, we're going to be looking at the sanitary load, and we want to have the theater with a count of 200, and we have another item over here. We want to add a unit load to element W1, and for the theater we want to move on to the shopping center. And then come over here for the shopping center. We want to have per employee, we have a count of 60. And then the last thing that we want to do is come over here to junctions, is new, initialize the unit loads for all elements. We only have one item here for the junction, which is going to be the school, and we're putting in 5 100 there. So now we're done with the sanitary load center. We can click out of that. Next thing we're going to do is look at the extreme flow factors. So we're going to come up over here to components and extreme flows. Select that, and then under the new, we want to come down and pick equation population factor. So what we're going to do here is change the name to Babbitt, and according to the information that I have here from page 3-66 is we want to have a cutoff value of 5,000, oh sorry, 5.000. C1 is going to be a value of 0. C2 is 5.0. C3 is 0.00. E1 is going to be 1.0. E2 is 0.20. And then moving on down here, the M1 value is going to be 0, and M2 is going to be 1.0. So now we've entered all that information, and we can close this out. And let's make sure that I've got all this done right. Now it's got capita, population capita. I need to change this to that. Now it matches the information in the Quick Start lesson number 1. So I'm going to close out of this. Next thing is that we want to do is select the extreme flow setups out of the components. And over here, we're going to go ahead and specify which extreme flow method is going to be applied and the constants that are associated with it and the multipliers. So you come over here and click on New, and then we're going to be entering the information from the Quick Start lesson. So over here we want to change the name on this is to the base extreme flow and extreme flow setup. In order to assign information here, we're going to need to click on these to make them editable. So the extreme flow method over here, you should be able to make this in all cases be Babbitt. Now I've selected all of those. My adjusted multiplier is going to be 1, 1, 1, 1 for all of these. And now I can close the extreme flow setups. And now what I need to come over is click the analysis menu, select the calculation options, and then come down over here and double click the base calculation options. And now what I want to do is taking a look at page 3-69 of the Quick Start lesson. I want to make sure that the time analysis type is set to steady state, which indeed it is, and that the calculation type is set to analysis, which it is. What I want to do now is look at the extreme flow setup, and come down over here. Here's my base extreme flow setup. Now I can close this dialog over here and get out of this. And I should now be able to click on the validation button, which is over here. And now I have a couple of errors I need to resolve. So let's take a look at what these have to say. And it says for P2, the pressure pipe stop invert is lower than the connected gravity node invert elevation. Let's see if I can. So a pipe stop invert set. It appears that what this is saying is that there's a mismatch between P02, the stop invert, and the elevation for outfall 1. So let's take a look. We're going to double click on outfall 1, and the elevation invert over there is 14. For P02, the invert stop is 14, so it doesn't appear to be a mismatch there. And then I've done some checking, and for P3, it appears that there's a mismatch between the wet well, which has a base elevation of 6 meters, and the elevation start for the P3 is 6 meters, so that doesn't appear to be a mismatch. Those seem to be erroneous messages. So at this point it appears as though that we have completed the setup of the SewerCAD design for the Quick Start lesson number 1. And all that remains is to click the compute button, which is over here. And we find out over here is that there's a problem with the version I'm using over here. The number of active pipes this model exceeds the number of pipes allowed in your license, which I think they have been corrected for the computer stations over IMET. But that concludes the lessons for the Quick Start lesson number 1.